Okay, Assalamualaikum to the invitees and participants. Thank you for attending the International Construction Week at FTK 2021. For information, our slot 10 will be divided into two parts with the title Bridge in Railway, Related Standard and Software, and the FEED Front-End Engineering Design Activities for Logistic Shore based on Yamdena Island, Indonesia. Please kindly ensure that microphone is in mute mode and the camera is open mode during this session. Your cooperation is deeply appreciated. Thank you. Ladies and gentlemen, a very warm welcome on behalf of the Organizing Committee International Construction Week at FTK 2021 to our distinguished guest speakers this evening, which is Mr. Muhammad Faizal bin Abdul Ghani and Mr. Mukhlis Islam on this virtual platform. Without further ado, we would like to invite Associate Professor Technologist Dr. Surayahani binti Adnan to conducting slot 10. Okay, Prof, the floor is yours.
Okay, thank you, Miss Akila, for a good as a chairperson for today's evening slot. Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon to all of the participants here. Okay, selamat petang semua. InsyaAllah kita harapkan semua sihat dalam keadaan walafiat semua. Okay, terlebih dahulu this session will be conducted in both language, in Malay and also in English. So first of all, kita sangat bertuah kerana kita ada special guest speaker kita pada petang ni, dan untuk makluman beliau merupakan alumni kita sendiri, iaitu alumni daripada UTHM. So diperkenalkan Encik Muhammad Faizal bin Abdul Ghani, okay, di mana sekarang beliau menjawat jawatan sebagai jurutera kanan, di mana kepakaran beliau adalah di bahagian jambatan. Jadi apa khabar Cik Faizal petang ni?
Ya, sama baik.
Okay, Alhamdulillah sihat ya. Sudah bersedia ya bersama dengan kita. Okay, jadi mungkin saya Surayahani binti Adnan daripada Jabatan Teknologi Kejuruteraan Awam bertindak sebagai moderator untuk sesi terakhir ya untuk kita punya iCIW Construction Week pada minggu ini. Jadi pada petang ni saya akan bacakanlah sedikit latar belakang Encik Muhammad Faizal, iaitu untuk makluman, Encik Faizal sekarang berkhidmat di syarikat AECOM Malaysia, di mana beliau mempunyai pengalaman selama 15 tahun di bahagian, boleh saya katakan agak pakar di bahagian jambatan, dan juga boleh saya bacakan sedikitlah berkenaan area-area kepakaran beliau, di mana beliau agak pakar di bahagian railway dan juga road bridge engineering. Beliau juga pakar di bahagian rail structure interaction. Beliau juga mempunyai kepakaran yang tinggi untuk balance cantilever bridge, concrete box girder bridge, dan juga untuk pre-stressed and reinforced concrete. Jadi saya harapkanlah semua mana adik-adik yang dapat menghadiri sesi pada petang ini, dan juga mungkin ada rakan-rakan daripada mana-mana yang jika ingin bertanyalah lebih lanjut berkenaan jambatan, boleh nanti bertanyakan terus kepada Encik Faizal. Dan juga untuk makluman, projek yang telah beliau terlibat adalah beberapa, seperti di projek Rapid Transit System ataupun RTS di Johor Bahru, Singapura. Beliau juga terlibat untuk projek MRT Singapura. Beliau juga terlibat untuk MRT Kuala Lumpur Line 1 Sungai Buloh Kajang, dan juga beliau juga terlibat di dalam projek LRT Palembang Indonesia, dan terakhir sekali untuk Damansara Shah Alam Elevated Highway ataupun DASH. Jadi boleh kita katakanlah sangat-sangat hebat kita punya bekas pelajaran ni, dan kita sebenarnya sangat kagum. Dan jadi saya rasa mungkin kita semua tidak sabar untuk sama-sama mendengar perkongsian daripada beliau berkenaan dengan tajuk beliau pada petang ini, iaitu Bridge in Railway Related Standard and Software. Jadi saya rasa tanpa saya melengahkan masa lagi, saya serahkan platform untuk selanjutnya kepada Encik Faizal. Dipersilakan Encik Faizal.
Terima kasih Doktor. Assalamualaikum semua. Sebenarnya hari ini saya rasa amat bertuah dan bersyukur dijemput oleh UTHM untuk berkongsi sedikit sebanyak ilmu yang ada. Okey. Sebenarnya Dr. Suraya atau Prof. Suraya ni adalah lecturer saya juga dulu. So, apa ni, tanpa membuang masa, saya share screen. Hari ni kita santai-santai je. Okey, tajuk kita pada petang ni Bridge in Railway Related Standard and Software. Saya just nak bagi pendedahan mungkin ialah apa yang kita praktis dekat dalam industri lah sebenarnya untuk bridge punya design lah. So mostly saya akan cover dalam bab-bab design lah. Okey, mungkin saya rasa ada juga subjek-subjek yang menyentuh pasal bridge lah. So mungkin sedikit sebanyak kita just saya nak introduce lah macam mana life seorang bridge engineer yang dekat AECOM lah. Sebenarnya AECOM ni dia worldwide company. Banyak lah cawangan-cawangan dia branch dekat seluruh dunia, antara Malaysia, Singapura, Indonesia, Thailand pun ada lah untuk yang dekat-dekat. Kebanyakan negara memang ada satu office untuk AECOM. Okey, saya share sedikit macam mana tu life seorang jurutera jambatan. So,
Hi, my name's Catherine Brown. I went to Loughborough University and studied civil engineering, and I now work in the Rail, Bridges and Structures team. In bridge engineering at AECOM, we do a number of things. So firstly, we go out on site and we inspect a number of bridges. We then tend to go back to the office and we'll put them into software and we will analyse and assess them. Then we'll also find out if any remedial work needs to be done and then go about designing it. Also, we design bridges from concept all the way through to detailed design. So one project I've really enjoyed being involved with whilst at AECOM are the number of bridge inspections that I get to be involved in. So this involves in 1 to 2 days a month I've been going out on site and actually carrying out the inspection. This can be done via a ladder or via a MEWP, so an elevating platform. It's quite exciting being able to go out on site and physically see the bridge that I will be inspecting. Once that's completed, go back to the office, I'll put all the information, all the defects noted, the condition of the bridge into a piece of software or draw it up on AutoCAD. I will then continue to analyse the bridge by hand calculations, so predominantly Excel spreadsheets. However, at a later stage, if it's a bit more complex, we can use finite element analysis to analyse the bridge. Once this is done, we'll be able to work out the overall capacity of the bridge and then give any recommendations to the client. So alongside my job, I'm also a STEM ambassador, and AECOM are really supportive with this, and they actually allocate 2 paid CSR days a year, which means I can go out to schools, I can talk to kids, I can run workshops. Currently, we've actually got some work experience students that I'm hosting. It's a really great opportunity to keep the connection with students still studying and inspire the future generation of engineers. So one of the really great opportunities I've had whilst being at AECOM is my involvement with charity work. So AECOM have actually offered for me to go to Peru for 10 days in September to help build a school for Indigenous Peruvian girls. Doing this, it really helps girls get into school, because a lot of girls out in Peru don't actually have the opportunity to finish off their education. So it's something that will really hopefully make a difference. as a graduate at AECOM, we do get the opportunity to rotate within the transportation field. So I actually started in streets and then I moved to bridges. It gives a really good opportunity to expand your skill set and learn about all different aspects of engineering. So one of my overall career goals is to become chartered with the ICA. So since joining AECOM, I've found a delegated engineer and a supervising engineer who've been really helpful in helping me fill out my development reports, going to monthly meetings, and overall kind of push my continual professional development, which will help me ultimately become chartered within 3 to 6 years.
Okay, to berkenaan dengan bridge engineer. Okay, konten apa ni discussion kita petang ni ada beberapa topik lah, ada beberapa benda lah. Okay, yang pertama introduction kepada bridge, lepas tu differences of railway bridge and road bridge. So design code and standard software to design railway bridge, rail structure integration analysis, and career after graduation, macam mana lah. Okay. So just nak apa ni cerita sikit pasal bridge. So dekat Malaysia ada beberapa jenis bridge lah. Kalau kita tengok, kalau kita perhati betul-betul, dia apa ni, structure dia lain-lain lah. So macam ni yang apa ni pelajar tengah tengok sekarang ni, dia adalah kita panggil beam and slab bridge lah. Okay, gambar ni adalah location dia dekat Pasir Ho, Kota Kelantan lah. Okay. So kalau beam and slab, kalau kita nak kenal jenis beam and slab bridge, kita ada beam, lepas tu on top of beam ni kita ada slab lah. So ini paling common lah apa ni type of bridge yang ada di Malaysia lah. Okay, next adalah box girder bridge lah. Sekarang ni in Malaysia benda ni common lah. So kalau kata kita sebagai bridge engineer, memang sekarang ni kat Malaysia memang kena tahulah untuk design box girder. Macam-macam jenis box girder. Box girder kita akan choose bila kita require long span lah. Normally more than 40 meter, 50 meter, dan kita akan choose box girder lah. So dia boleh pergi sampai 100 lebih meter lah untuk box girder. Okay, next pasal cable stay bridge. Ini ada di Malaysia tapi dia memang jarang-jarang ada lah. So yang macam kita tahu dekat Jambatan Pulau Pinang, second Penang bridge, itu memang guna cable stay bridge lah. Ini quite specialist lah untuk buat benda ni. Okay, next yang kita selalu tengok mungkin dekat internet, suspension bridge, Golden Gate Bridge, San Francisco. Ini paling panjang, kira span yang panjang yang kita maksudnya kita tak mau letak pier ke dekat tengah, kita choose structure yang macam ni lah, cable stay. Okay, next pasal differences of railway bridge dengan road bridge. Okay, railway bridge ni kalau kita tengok dia punya bridge, jarang kita akan choose structure yang long span sebenarnya, kecuali kita terpaksa buat. Dan bila kalau kita buat apa ni railway bridge yang long span, kita kena ada mitigation plan untuk rail sebenarnya. So untuk road bridge pula, kita boleh buat long span, tak ada masalah, dan kita boleh buat continuous flow type. So bila continuous mungkin structure depth boleh kurang, maksudnya macam tu. So dia punya structure tu tak bulky lah compare dengan railway bridge. Sebenarnya kita kena buat, kita more prefer simply supported bridge ni sebab sebenarnya temperature, sebab kita nak avoid dia punya large expansion structure. That's why kalau kita tengok untuk LRT ke MRT ke, dia akan buat simply supported, kecuali dia nak cross highway ke, dia nak cross apa, dan itu memang terpaksa buat long span, dan dia ada mitigation untuk control stress lah. Dari segi loading pula, railway bridge memang heavy daripada road bridge lah semuanya. Okay. Dia punya cross section untuk railway, bila kita tengok macam ni, dia nampak ada macam satu benda untuk rail install lah, install on top of bridge. So ini kita panggil platform. So berbagai-bagai jenis sebenarnya benda ni. Ada yang kita boleh letak balas, ada yang macam bentuk, kalau kita tengok macam batu-batu semua tu. So untuk on top of bridge ni, kita prefer kita letak platform concrete lah. So atas ni kita ada dia. So ada dia. Dekat tepi-tepi ni ada services lah, M&E, dan ada maintenance walkway atau emergency walkway dekat tengah. Sectionnya macam ni. So train akan ikut rail. So dia tak akan pergi ke tepi ataupun ke tengah lah. Tapi untuk loading pula sebenarnya, bila kita design, dia ada satu case kita off track, benda ni accidentally terkeluar. So kita panggil derailment. Ada juga loading kita akan letak di luar daripada rail sebenarnya. Okay, kalau kita tengok road bridge pula, loading untuk traffic, dia akan pergi daripada hujung ke hujung. So kita kena analisis daripada hujung ke hujung. Kalau macam ni, kalau macam untuk railway, kita mau straight line je lah. Okay. Untuk loading pula, okay, sekarang ni dekat Malaysia, kalau dekat Malaysia lah, so kita masih lagi praktis British standard sebenarnya. Kalau dalam kelas, tak salah saya, kita dah move kepada Euro code lah. So tapi kalau bila dah masuk kerja lah, maksudnya kan kita nak praktis dekat private company, consultant ke apa ke, klien-klien banyak lagi mesti lagi prefer BS lah. So untuk live load, BS 5400 akan cover untuk loading traffic dengan loading railway lah, ataupun DD 3701. So kod untuk loading macam ni lah dia punya page. BD 3701. So ini adalah loading railway bridge juga yang ada dalam Eurocode lah. So kita ada type load model 71 dengan load model SWO, SWT. So dia akan cover dalam Eurocode tu part 2. Sorry, this one part 2. Okay, tadi untuk load, tapi untuk design pula macam biasa, BS 5400 part 4 untuk cover concrete design. So untuk Eurocode yang ni saya rasa ada kelas pun adalah belajar lah untuk design. Untuk bridge kita akan refer kepada part 2 lah. Part 1-1 ni standard lah untuk building kita akan guna ni. So untuk yang part 2 cover untuk concrete bridges lah. Okay, itu pasal kod lah. Untuk software pula, kebanyakan konsultan kat Malaysia dia akan selalunya akan guna software ni Disember. Ciri-ciri software yang untuk design railway bridge ni, dia mesti boleh buat village modeling dan analysis. Lepas tu dia boleh buat convection stage, time dependent effect, non-linear analysis, dynamic analysis, gray structure iteration lah. So kalau software tu provide semua benda ni, maksudnya kita boleh perform design guna software tu lah. So kalau kata besok keluar kerja kat konsultan, mungkin akan guna software ni lah, Disember. Next, benda yang sama juga, ini adalah
Cik Faizal, minta maaf. Boleh minta kuatkan sikit suara tak? Ada permintaan. Minta maaf ya.
Ni adalah driver kepada My Disember tadi, Bentley RM Bridge. Bentley RM Bridge sama juga dia punya function dia, village modeling semualah sampai ke rail structure iteration. So kalau kita tengok, ni adalah model bridge untuk MRT Singapore, long span railway bridge. Dengar tak suara?
Dengar.
Saya dengar.
Dengar.
So dalam software ni kita akan model box girder punya section, kita akan ada tendon, so kita akan dapat result bending moment ataupun concrete stress. Kita akan dapat daripada software ni lah. Next, as a bridge engineer mesti kena tahu Stack Pro lah. Saya rasa ini pun universiti ada ajar. So kalau kata minat untuk jadi structure engineer, kena fokus lah untuk Stack Pro ni. Ini adalah starting software, memang mesti kena tahu Bentley Stack Pro. And next adalah Autodesk Structure Bridge design lah. Ini pun memang common lah, kita akan guna. So starting akan guna dua-dua benda ni. So take note kalau kata minat structure, bridge structure. Next, saya nak cerita pasal rail structure iteration. Sebenarnya kan, mungkin saya sendirilah sebelum terlibat dengan bridge engineering kan, saya tak fikir kita kena analisis sampai ke rail structure iteration kan. Kita kena analisis rail. So bukannya kita simply letak je rail tu. So kalau kita simply letak je rail tu, ini adalah sebahagian failure punya rail akan terjadi. Rail akan jadi bengkok, sama ada bengkok ataupun putus lah. So untuk kita analisis benda-benda ni, so kita kena refer kepada UIC code lah, 744-3, track bridge iteration. Kalau kata dia sebenarnya more on temperature lah sebenarnya. So kalau kata temperature rise, so rail ni akan membakar. So kalau kata temperature drop, so dia akan rail ni mungkin boleh putus ataupun crack ke whatever lah, disebabkan oleh temperature drop. So ini adalah graf untuk kita testing rail fastener. Ini adalah rail fastener. Dia sebenarnya untuk fixkan rail ni, dia ada fastener. Fastener ni bukan dia direct screw dekat rail ni. Dia just macam dia kepit rail ni. So rail ni sebenarnya dia boleh slide atas ni. Selalunya kita akan pasang stiffener ni every 600-650 lah spacing. Okay, so ini adalah track behavior lah. Behavior. So ini adalah apa ni, resistant dekat track. Untuk type gravel, dia akan dia punya resistant untuk unloaded punya case, maksudnya tak ada train atas tu, dia up to 20 km per meter lah. Kalau loaded, dia akan pergi ke 60. So dia akan lagi stiff lah dia untuk slide. So maksudnya loading kalau lebih 60 kN per meter, rail tu akan slide dengan apa ni, fastener tadi. Okay, ini untuk type gravel. Lepas tu untuk kalau kata on top of bridge, value dia 40 dengan 60 lah. Ini adalah graph lah, ada dalam iCIW tadi. Okay, so basically-nya apa ni, kita akan check thermal load based on plus minus 20 darjah Celsius lah. So untuk loading next-nya adalah acceleration dengan braking load lah. So load kita ada 3, thermal load, acceleration, braking load dengan vertical train load. Okay, untuk analisis ni kita akan guna rolling stock lah. So biasanya rolling stock berbentuk macam ni, kita ada 4 train ataupun 6 ke, ikut atas projek punya spec lah. So untuk projek ini adalah rolling stock untuk projek RTS dekat Johor lah. So kita ada setiap axle kita ada 130 kN. So kita akan load atas rail tu dan kita analyze. So kita akan dapat stress lah. Thermal load due to thermal, acceleration and vertical load daripada train. So end up semua ni kita akan dapat berapa stress. So dia punya limitation, kita tak boleh lebih 72 Newton per mm2 in compressive dan juga 92 Newton mm2 in tensile. So ini adalah salah one of the criteria yang kita kena meet. Sebenarnya ada beberapa lagi kriteria yang kita kena meet. Dia punya deflection, semualah benda tu. So saya rasa benda tu agak panjang juga untuk explain dekat sini lah. So basically-nya untuk railway punya bridge, kita design bridge tu, kita nak kena study further on rail structure interaction sebenarnya. Okay, untuk bahagian ni mungkin ada apa-apa soalan yang mungkin nak tanya?
Okay. Ada apa-apa setakat ni yang mungkin boleh dilontarkan pada Encik Faizal? Ada? Okay, setakat ni belum ada lagi Encik Faizal. Mungkin nanti di hujung sesi nanti, insyaAllah.
Okay, satu lagi benda saya nak cerita. Okay, ini pasal teknikal. Kalau kata nak tanya apa-apa nanti lepas ni boleh tanya juga. Okay. So next, kita nak cerita pasal career and after graduation lah. So lepas grad ni agak-agak nak kerja macam mana? Kerja yang macam dalam gambar ni, saya rasa kebanyakannya pernah tengok gambar ni. So macam ni ke kita punya keadaan selepas grad? Taklah kot kan, engineer tak macam ni lah kot. Ni kalau dalam drama boleh lah. Okay, so dah grad kan. So nak kerja apa sebenarnya? Pernah terlintas tak? Nak buat apa lepas grad? Okay, lepas grad yang maksudnya yang mungkin yang agak biasa lah saya cerita kan. Mungkin boleh buat further study, master atau sambung PhD. Okay, mungkin boleh buat yang itulah. Dan juga okay, boleh juga apa ni, pelajar-pelajar nak pergi kerja dekat government, mungkin boleh minta JKR, mungkin boleh minta government body yang lain-lain, tak kisahlah kementerian apa-apa. So mungkin juga boleh pergi kerja government lah. Okay. So next, mungkin juga boleh pergi kerja dekat private sector. Private sector contohnya Jonas, mungkin juga boleh pergi dekat apa-apa company yang private lah, maksudnya bukan badan kerajaan lah. Ataupun buat bisnes. Selalunya kebanyakan antara kita lah lepas graduate, dia akan pergi ke private sector lah. Okay. So private sector ni dia ada pecah kepada beberapa lah. Ada klien, contohnya macam Petronas, itu klien lah, kita sebut macam kita sebut sebagai klien. Kita ada juga konsultan. Konsultan contohnya AECOM lah. AECOM adalah konsultan. Konsultan ni tugas-tugas konsultan ni selalunya kita akan buat design dan konsult klien macam mana kita nak menjayakan sesuatu projek lah. Buat design, consult everything. Okay, so satu lagi kontraktor. Kontraktor ni adalah pihak yang akan menjalankan kerja-kerja pembinaan. Okay, so ini adalah pecahan-pecahan dia lah. Okay, untuk CNS consultant, kalau kata lepas grad nanti, nak kerja dekat consultant, so kita akan apply dekat CNS consultant lah. Kat KL ni banyak apa ni, consultant yang ada, contohnya AECOM, contohnya WSP, contohnya SSP, contohnya Zaidongdin, banyak lagi lah. Itu adalah consultant. So kontraktor pula, contoh-contoh kontraktor banyak juga, contohnya Zaki, macam tu lah. Orang company yang buat construction. Kita adalah company yang apa ni, buat design lah, consultant. Okay, pergi dekat consultant pula, selalunya consultant akan pecah kepada beberapa bahagian lah. So ada department civil. Okay, lepas tu selalunya dia akan ada department structure. Dan satu lagi dia akan ada department geoteknik. Okay, so selalunya tiga ni adalah department terbesar yang akan ada dalam CNS consultant. Okay, so dalam civil pula, dia akan ada infrastruktur punya engineer. Biasa kita panggil infra engineer lah, engineer infra lah. Satu lagi akan buat design road under infra juga. So kita panggil road engineer. Okay. Okay, so kepada structure pula, dia akan pecah kepada dua, iaitu bridge dan satu lagi building. Ini adalah structure lah, bridge dengan building. So geoteknik lah. So dalam banyak-banyak ni lah, apa ni, pada pandangan saya lah kan, dalam banyak-banyak ni lah, sekarang ni market dekat luar sana, dia banyak demand dekat road engineer dan juga bridge engineer. Supply kurang, demand banyak. Road engineer ni sebenarnya dia akan buat alignment road dan juga alignment untuk railway. Dia boleh buat dua. So apa ni, untuk demand sekarang kat Malaysia pun ada demand, dekat overseas pun ada demand untuk bridge dengan road. Kalau kata minat, so mungkinlah boleh pergi dekat road ataupun bridge. Yang lain pun okey juga, bagus juga. ikutlah terpulang pada selera masing-masing lah. Tapi apa yang saya cakap tu apa yang saya nampak dari segi demand sekarang lah. Okay. Geoteknik pun bagus juga, semua bagus, tapi yang saya nampak itu yang saya ceritakan. Okay, lepas study tu mungkin terfikir nak kerja lah kan. Kita fikir mungkin nak kerja macam tu kan. So saya suggest lah kan, kerja boleh. Masuk kerja tu maksudnya kita cari peluang kerja untuk mencari peluang bisnes sebenarnya. Kalau boleh siapkan dalam fikiran kita, aku nak kerja, aku nak timba pengalaman, aku nak cari experience, aku nak buat bisnes. Supaya at the end aku boleh maksudnya create peluang pekerjaan kepada engineer baru, maksudnya macam tu. Okay. So mungkin dalam bidang simple kita tak berapa terdedah kepada macam mana kita nak buat bisnes sebenarnya. Okay. Lepas dapat experience kan. Okay, kata kita nak choose kepada bidang bisnes, apa yang kita kena buat sebenarnya kan? Kena create company. Okay, create company. Start dulu dengan company enterprise. Okay, yang orang kata juga sole prop. Company enterprise. So macam mana nak create company? Kena create dekat SSM. Surat Jaya Syarikat Malaysia. Okay, ni first step. Okay, next step. Kita kena register dengan CIDB. Okay, CIDB pula kita boleh register dekat website dia lah, cims.cidb.com.my. Okay, kita register dekat CIDB. Lepas tu kita kena register untuk dapatkan sijil pengakuan pendaftaran PKK. Ini wajib kita register lah. Next step, kita kena dapatkan registration untuk SPKK, sijil perolehan kerja kerajaan. Okey, ni kita kena ada. Contohnya kita nak dapatkan kerja-kerja daripada sektor kerajaan, memang kita kena ada SPKK. Kalau kita nak buat secara tak masuk kerajaan lah, private, PKK pun dah cukup. Okay. Next, kalau kata siapa yang boleh memohon untuk Bumi Putra, apply sijil taraf Bumi Putra STB. Apply sijil taraf Bumi Putra STB. Okay. Ini adalah satu jalan untuk buat bisnes. Okay. Dengan berbekalkan ilmu yang ada dekat universiti, dekat tempat yang kita kerja pada awalnya. Okay. So salah satu lagi cabang adalah kita kena daftar kita punya syarikat dekat Kementerian Keuangan, MOFE perolehan.gov.my. Okey, kita daftar syarikat kita. Dalam MOF ni dia ada banyak kod bidang. Tengok kod bidang kat situ, senaraikan mana yang kita rasa kita boleh buat dan kita boleh melakukan kerja tu, dan kita daftarkan kod bidang tu. Register kod bidang. Contohnya kod bidang 031356 ke, kita daftar. Kita boleh daftar sehingga 30 kod bidang untuk MOF. Selalunya MOF adalah cabang macam mana kita nak maksudnya supply sesuatu benda. Contohlah kan, universiti perlukan bahan binaan untuk student-student kan. So kita boleh supply bahan binaan dengan adanya kod bidang tertentu. Okay. Dan seterusnya kita apply sijil akuan pendaftaran syarikat Bumi Putra. Ini untuk yang Bumi Putra lah. So boleh terus daftar. Dan selepas ada benda-benda ni semua, cari projek. Okay, cari projek, tak kira projek swasta ke atau government. So dengan adanya projek ni, kita boleh create peluang pekerjaan. So maksudnya kalau yang nak bisnes tu ambil pengalaman daripada awal. Kerja susah tak apa, tak kisah, ambil pengalaman yang penting. Jangan fikir nak gaji besar ke, nak kerja yang kurang penat ke, apa ke. Sebenarnya kan, apa yang saya boleh cakap kan, kita kalau habis universiti kan cari kerja yang kurang penat, kurang kerja apa semua, kita akan suffer at the end. Kalau boleh cari kerja yang semua benda kita kena buat, itu yang paling bagus. Okay, gain ilmu sebanyak mana yang ada, sebanyak mana yang boleh. So untuk bekal kita seterusnya. Okay, so itu antara benda yang saya boleh cadangkan lah, saya boleh kongsikan untuk pelajar-pelajar semua. Okay, ada soalan?
Okay, ada apa-apa nak tanya? Boleh kemukakan pada Cik Faizal nak, kalau segan atau ni tapi teringin nak tanya, boleh tuliskan juga dalam chat box ataupun boleh komen di dalam Facebook, ataupun kalau rasa ingin terus bertanya secara langsung dengan Cik Faizal pun sangat-sangat dialu-alukan. Okay, tak apa Cik Faizal, mungkin saya boleh mulakan dulu sedikit persoalan. Mungkin saya bertanyalah, maksudnya Cik Faizal, since maksudnya habis dia graduated tu daripada UTHM, adakah terus macam dapat pekerjaan ataupun macam mana dan daripada proses tu boleh tak saya tahu, macam normally selalunya lah kalau kita menceburi bidang pekerjaan ni especially dalam civil engineering, dia selalunya lah yang saya nampak dia bukan terus jump pergi kepada bridge kan, dia tidak pergi kepada jambatan. Selalunya dia akan pergi kepada building dulu, macam tu kan. So macam mana boleh pula terjurus ke arah jambatan tadi tu, pembinaan jambatan. Okay, mungkin boleh Cik Faizal kongsikan sedikit.
Okay, saya kongsikan sedikit lah pasal benda ni. Sebenarnya kan, saya dulu selepas grad tu, saya tak tahu konsultan ni macam mana. Saya tak tahu dalam tu ada building, ada bridge, road, apa semua saya tak tahu. So depend kepada company yang saya pergi tu, dia ada kekosongan apa. Okay, maksudnya saya just ambil je lah. So buat dia tak semestinya kita kena pergi dekat building dulu ataupun pergi mana-mana dulu untuk kita buat bridge. Kita boleh juga apply bridge sebenarnya. Dia sebenarnya perbezaannya dari segi loading lah untuk kita buat design. Untuk structure sebenarnya design apa yang kita belajar dekat kelas tu lebih kurang sama. Different, ada sikit-sikit lah dalam code tu. So kalau kata minat untuk bridge, boleh terus mungkin tanya dekat konsultan tu, ada tak kekosongan untuk bridge engineer. Kalau kata ada kekosongan untuk bridge engineer, then try dapatkan, mintakan untuk dapatkan jawatan bridge engineer lah. Okey, untuk jadi bridge engineer kan, subjek-subjek yang dalam kelas tu yang yang patut kita tekankan adalah reka bentuk, struktur, mekanik bahan, semua tu memang kita kena kuasai betul-betul lah sebenarnya. Okey. Formula-formula yang dalam subjek-subjek tu, formula utama tu memang kena ada dalam kepala lah. Sebenarnya macam mana nak kira riba semua memang kena ingat lah. Kalau boleh dengan ada kalkulator kita dah boleh kira berapa riba kita perlukan, share berapa, kita kena sampai structure engineer sampai kena tahap macam tu. Tak perlu refer buku. Ada case kira bending moment, kira riba terus, dapatkan terus. Kena praktis. Buat banyak-banyak kali.
Okay, saya setujulah tu. Saya memang kebetulan kan saya sendiri pun memang daripada dulu, kalau Cik Faizal masih ingat, memang antara subjek yang saya ajar memang adalah mechanics material, structure analysis ni kan. So saya seperti juga dah dibuktikan lah Cik Faizal kata betapa penting lah
memang penting. Subjek tu memang penting untuk structure. Dia bukan melibatkan kita nak design. Dia peringkat analisis tu kita dah kena ambil tahu semua benda pasal benda tu.
Ya, betul. Okey, saya juga tertariklah tadi dengan cadangan Cik Faizal berkenaan dengan menceburi bidang perniagaan kan. Jadi maksudnya selalunya dalam berapa lama masa yang paling sesuai selepas telah menceburi bidang pekerjaan untuk switch pula ke arah bidang perniagaan. Mungkin rasa-rasa dah mencukupi kepakaran kita tu sampai tahap mana baru kita boleh offer pula kepada orang lain untuk menggunakan kepakaran kita.
Okey, untuk design saya rasa untuk kita buat kerja-kerja design mungkin kita kena ada experience sekurang-kurangnya 5 tahun untuk kita buat design yang simple-simple. Macam contohnya untuk design balance cantilever, box cutter apa semua tu, memang yang tu memang agak rumit, tapi bila kita dah start buat, bila kita dah buat dan dia okey lah, mungkin yang tu 7-8 tahun dan okey lah tu. Untuk masuk ke bidang perniagaan pula, okey, kita kena set daripada awal. Kalau kita minat berniaga, kita kena set apa yang kita minat berniaga. Kita nak berniaga secara kontraktor ataupun kita nak berniaga secara konsultan, kita sebagai konsultan atau macam mana. Untuk yang paling saya rasa paling cepat untuk masuk dalam bidang perniagaan, mungkin boleh pergi dulu dalam bidang projek.
Okey, baik. Okey, Cik Faizal, dalam chat box ni ada sedikit soalan. Dinyatakan di sini, Assalamualaikum sir. Untuk design bridge, standard apa yang perlu kami guna untuk design? Maksudnya macam design beam, column support, deck dan juga abutment. Maksudnya mungkin adakah setiap tu mempunyai spesifik standard ataupun daripada standard yang sama kita boleh gunakan untuk design untuk semua item dalam bridge.
Okey. Kalau kata dekat konsultan, dekat local konsultan sekarang Malaysia, kita masih lagi praktis guna BS5400. Dia different building dengan bridge. Building selalunya building engineer akan guna BS8110. So untuk yang bridge kita akan guna BS5400. Dalam 5400 tu ada 10-11 part dalam tu. So BS5400 ni akan cover semua elemen untuk design jambatan lah. Sama ada steel tak salah saya part 3 kot. Kalau untuk concrete part 4 BS5400. So kalau kata mungkin pernah mungkin dekat universiti selalu akan tengok BS8110. So bila masuk konsultan untuk design bridge, kita akan kena ke BS5400. Okey.
Okey. Terima kasih. Okey. Okey, saya bacakan lagi ni. Ada nampaknya soalan baru juga. Okay, good afternoon, Mr. Faizal. Is there any consultation in green building in Malaysia? Is it a demanding job? And what's your opinion about it? Since climate change is the most widely discussed right now. Okay, thank you.
Green building Oh, saya tak berapa saya tak berapa aware sangat pasal green building. Tapi memang sekarang setahu saya tu kena tanya engineer lah. Tapi setahu saya memang ada demand untuk green building. Tapi untuk sekarang ni lah di Malaysia banyak projek building ni dia agak slow sikit lah. Saya tak tahu sebenarnya, tapi dari segi pengamatan saya ni projek building agak slow sikit. So yang terus berjalan adalah projek yang melibatkan infrastruktur. Contohnya jalan raya, contohnya MRT, contohnya jalan-jalan kereta api. Okey, projek-projek ni dia terus berjalan. Over the world sebenarnya. Walau macam AECOM kan. Saya dekat Malaysia. So kita buat juga design untuk Singapura, untuk Indonesia, kita buat juga. So over the world sebenarnya. Untuk yang building ni, dia sebenarnya pendapat saya lah kan. Building ni dia punya supply banyak compare dengan base engineer. Base engineer supply dia kurang tapi demand dia banyak. Itu pada pandangan saya lah.
Okay.
Kalau kata bridge ni kita boleh pergi over the world. Maksudnya kita boleh kerja dekat Singapura, kita boleh kerja dekat Dubai, kita boleh kerja dekat UAE, mana-mana pun selalunya banyak permintaan lah untuk tapi untuk building pun okey juga. Sebenarnya semua okey. Tengok atas keadaan semasa lah. Tapi buat masa ni infrastruktur yang terus rancak berjalan lah. Okey.
Okay, terima kasih Mr. Faizal. Okay, di chat box ada lagi soalan di sini. Boleh saya bacakan daripada Ainin Sofia. Sir, saya ada satu lagi soalan. Apakah beza antara British Standard dengan Eurocode? Adakah kedua-dua standard ini sesuai untuk digunakan semasa design atau perlu refer kepada satu standard sahaja?
Okey, ni ada soal saya macam tak okey je. Sebenarnya Eurocode ni adalah satu updated code lah compare dengan British BS ni adalah satu kod yang lama. So sebenarnya dia adalah badan yang sama, BSI. So dulu dia ada kod British Standard, sekarang ni dia update kepada Eurocode. Sebenarnya benda tu lebih kurang sama. Kalau kita tengok antara kedua-dua ni, BS punya design dia akan more kepada strength, cube strength untuk konkrit. Kalau untuk Eurocode dia akan pergi kepada cylinder strength. Sebenarnya lebih kurang sama lah benda ni. Tapi untuk Eurocode punya checking dia ada sesetengah benda yang agak detail sikit lah dia akan pergi. So itu je lah. So nak design BS pun boleh, nak design Eurocode pun boleh. Tengok atas pada klien lah. Klien setkan apa dia punya requirement dia. Kalau kata BS kan boleh kita boleh kita go for BS lah. Tapi tak salah saya sekarang ni dekat Malaysia ni Kenapa kita masih lagi adopt US? Sebab kita punya akta sebenarnya. Mungkin akta kita ni tak salah-salah. Mungkin akta kita ni dia tak revise lagi kepada Europol. Masih lagi UBBL. Lepas tu UBBL tu cerita pasal beauty standard, bla 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 bla. Benda ni tak diupdatekan. Kalau kata dah diupdatekan, dah digazetkan betul-betul, then semua construction dekat Malaysia ni kena guna Europol. Itu pandangan saya.
Mungkin Cik Faizal saya nak tahulah. So normal practice sekarang memang klien banyak prefer using the Europol or the British standard.
Kalau buat masa sekarang ni, kalau kat Malaysia British standard lagi, masih lagi British standard. Walaupun ada kita galakkan, tapi dari segi real project orang masih lagi adopt BS kalau kat Malaysia. Tapi kalau design yang melibatkan Singapore punya structure, itu kita akan guna Europol lah, kita akan adopt Europol lah. Macam contohnya projek RTS ni, dia adalah satu laluan kereta api daripada Johor Bahru ke Singapura. Benda ni akan bersambung daripada Johor Bahru ke Singapura. So kita Singapura dia adopt Europol. So untuk kita standardizekan semua, projek ni kita guna Europol lah untuk RTS. Walaupun kalau untuk macam MRT line 1, line 2 dekat KL ni still lagi adopt BS, British Standard. Kalau projek yang melibatkan international semua macam tu, dia adopt Europe lah.
Okay, Cik Faizal, so saya rasa mungkin this one is the last question lah. Saya boleh bacakan daripada Sheikh Kian Wen. Okay sir, could I know that what are the essential skills that are needed to be successful in future? Apa dia kemahiran yang sangat-sangat rasa memang perlulah untuk berjaya masa hadapan?
Kemahiran yang perlu berjaya, yang perlu ada untuk berjaya. Okay, sebenarnya kan pada pandangan saya kan, fikir di luar kotak. Kita kena fikir di luar kotak. Kita kena alert dengan keadaan semasa. Kena fikir apa yang akan jadi dekat sekeliling kita 5 tahun akan datang, 10 tahun akan datang, 20 tahun akan datang. Kita cepat-cepat kena menyesuaikan diri kita dengan keadaan yang mungkin akan terjadi pada masa hadapan. Contohnya kan, kita fikir salah satu benda tu dari segi perjalanan masa. Satu benda tu dia dah banyak automation, satu benda tu dia tak lagi manual buat sesuatu benda. So kita fokus kepada benda yang automation di masa hadapan, yang kita jangka akan berlaku lah. Kita jangan maksudnya di tempat yang sama, macam di persekitaran yang sama. Kena fikir dekat luar kotak daripada sekarang. Macam contohnya habis grad mungkin tak fikir pun macam mana kita nak contohnya nak gain income ke kan. Kita fikir kerja kan, tak salah nak kerja. Tapi sebenarnya macam mana sebenarnya kita nak gain income kita adalah sebenarnya kita kena ada juga bisnes sebenarnya. Kena menceburi dalam bidang bisnes. Macam contohnya, tak kisahlah kontraktor ke macam mana ke kan. So itu sebenarnya satu ruang untuk kita gain. Jangan kita fikir lepas tu nak kerja lah sampai habis kan. So dia sebenarnya cuba plot graf income business dengan income untuk kita maksudnya kerja je. So maksudnya kena prepare apa benda yang kita nak kena buat nanti daripada sekarang. Tak salah, ikut minat masing-masing, tak salah. Tapi kalau kata rasa macam business tu okay, then go for business. Tak salah nak kerja mana-mana pun, swasta ke, kerajaan ke, nak jadi apa pun tak salah, semua bagus. Dia saling melengkapi. Tapi depends pada apa yang kita nak.
Okey, Cik Faizal, tadi saya cakap last question tapi nampaknya ada sahabat kita, Cik Khairi dia daripada tadi angkat tangan, ni saya tak nampak, minta maaf. Okey, Cik Khairi mungkin boleh tanyakan secara langsung dengan Cik Faizal. Ada lagi ke Cik Khairi?
Ada.
Okey, silakan.
Assalamualaikum Cik Faizal.
Waalaikumsalam Cik Khairi.
Ya.
Lama tak dengar suara.
Ni saya ada soalan.
Okay.
Boleh tak Cik Faizal bagi pandangan lah jika pelajar-pelajar kita yang kata dari segi performance, dari segi subjek ataupun kursus di universiti, contohnya subjek yang core, design ataupun structure analysis, mechanic material, dia punya result tu memang dah tak dapat A lah, tak dapat A, B apa semua kan, mungkin C ataupun D kan. Masih ada peluang lagi ke untuk dia mendapat tempat di bidang ni lah, consultant punya design firm. Dan kalau boleh Encik Faizal boleh kongsikan apakah perbezaan di antara sesi pembelajaran di universiti untuk setengah subjek, contohnya subjek design kan, berbanding dengan apply bila bekerja di consultant. Itu saja Encik Faizal.
Okey, terima kasih Cik Khairi. Kalau kata subjek tu dah terlepas kan, sebenarnya dia atas minat lah. Kalau kita minat untuk design, masa tu mungkin tak ada kesedaran lagi kan, kita minat untuk design. So buka balik buku-buku design apa semua tu, benda-benda asas. Contohnya macam mana kita nak design kita nak design member, kita nak design column, kita nak design semua benda tu, buka balik. Lepas tu buatkan buatkan nota padat, study betul-betul benda ni. Ingat segala formula asas, ingat balik. Lepas tu contohnya macam formula untuk simply supported beam, continuous beam, semua benda tu ingat. Lepas tu formula mekanik bahan yang asas-asas pun, semua benda-benda tu ingat. Then hafal, get ready sebelum interview. So masa interview tu mungkin para pelajar boleh kata boleh tunjuklah yang sebenarnya walaupun biasa yang lepas tu tak dapat cemerlang sangat, tapi mungkin dari segi di universiti terlibat dengan bengkel-bengkel, dan kita refresh balik formula ni, dan cara-cara nak design apa semua, dan kita ada, maksudnya student ni ada improvement lah dalam dalam kerja-kerja design ni. Okey, dan satu lagi apa tadi? Satu lagi. Yang pertama sekali adalah ada peluang ke tak kalau kata dapat grade yang sederhana lah maksudnya kan. Okey, yang kedua, apa beza pembelajaran dalam kelas dengan dekat luar yang untuk kita praktis. Sebenarnya dari segi formula semua tu tak ada beza lah, memang tak boleh nak ubah pun. Dari segi practicality lah sebenarnya. Contohnya dalam pembelajaran dalam kelas, contohnya kita nak design satu beam tu. Dalam kelas tu dia ada formula macam mana kita nak set beam depth contohnya kan. Beam depth. Dia ada formula. Dan kita pun kira lah berapa dia punya beam depth. Contohnya kira dapatlah 435 atau 497 mm depth. Itu pun kira. Benda tu dalam PSA tak salah lah. Kalau kata jalan kira apa semua betul, then okey lah, straight mark lah. Tapi dekat luar, kita kena fikir logik ke tak kita buat beam depth 497 ke 475, sama ada benda tu common ke kita nak buat dekat site. Maksudnya workers nak pergi ukur sampai 435. Kita kena ambil satu size yang agak mudah, contohnya 400.5. Okey. 400, mungkin 500. Maksudnya macam tu lah. Maksudnya kita dalam kelas tu mungkin ada formula untuk kita setkan benda-benda ni semua. Itu sebagai guidance kita. Tapi bila dekat luar, kita kena meshkan dengan dengan practicality dekat luar. Macam mana? Okey?
Okey, terima kasih Cik Faizal. Saya rasa perkongsian pada petang ni menghangatkanlah suasana yang mungkin agak sejuk ni. Alhamdulillah. Jadi saya ucapkan juga berbanyak terima kasih di atas perkongsian yang sangat bermakna daripada Cik Faizal, dan juga saya rasa banyak juga tadi yang boleh saya simpulkan antara perkongsian di luar kotak lah sebenarnya yang cuba Cik Faizal beritahulah kepada mungkin pada adik-adik yang selepas ni yang akan bergraduan selepas ni. So apa perkara pertama yang mungkin boleh dilakukan lah. Maksudnya jangan rasa blank apa, rasa macam lagi sekarang macam semua orang dah ada degree, macam mana nak ni. Jadi itulah antara tips-tips yang telah diberi oleh Cik Faizal tadi. So terima kasih Cik Faizal. Okey, jadi mungkin saya rasa kita sekarang boleh teruskan pula untuk part 2 untuk slot 10 ni.
Okey, terima kasih Doktor.
Okey, terima kasih. Boleh stopkan ni sharing ni Faizal. Okey. Okay, so Alhamdulillah, now we turn to the second part for our slot 10 for today. So please welcome our special guest from Universitas Bengkula, Mr. Mukhlis Islam. So Mr. Mukhlis Islam.
Yeah.
Right, okay, how are you?
Alhamdulillah. No complaint.
Alright. Okay, so for some introduction, Mr. Mukhlis Islam is the head of program for Department of Civil Engineering from Universitas Bengkulu. And maybe for this evening, I would like to share some of his background, which his education is in the Islamic University of Indonesia, Yogyakarta, and then he proceed for his degree in structural engineering at Gajah Mada University, Yogyakarta. Okay, he is a very specialist in structural engineer, and as we can see in his resume, he has a lot of experience conducting for the projects involving of the structural. So maybe for this evening, he will share with us to the talks with the title, the FEED or front-end engineering design activities for logistics shore based on Yamdena Island, Indonesia. Okay, Mr. Mukhlis, so this platform is yours. Okay, thank you.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. I would like to share screen of my. Today, I will talk about the feed or front end engineering design activities for logistics shore base in Yamdena Island, Indonesia. During the project, I was the PMT1 engineering manager for the project, but currently I'm the head of Civil Engineering Department of Faculty of Engineering, Universitas Bengkulu. Dr. Suraya already introduced me. That I am the specialist in civil engineering, structural engineering, but unfortunately or fortunately, I'm not going to talk about structural engineering right now. I will talk about the other, or may I say, happy side of engineering works. Because at the time I didn't function as the structural engineer. I was the engineering manager of the project. The purpose of the project is to build the LSB, or we call it logistic shore base, to accommodate and support Masela operational, which are drilling, surf, FLNG, and other operational, including logistic supply, personnel movement, and etc. Yeah, this was the project location. So if I may show you, this is our PSC block, our gas well. Yeah. In order to support the activity of the offshore activities of exploration of the Abadi block, we need to build shore base. Why we need to build a shore base? Because the block is pretty remote from any major cities in Indonesia. The Masela block is 150 kilometers from Yamdena Island itself, and then 2,600 kilometers from Jakarta, and 400 kilometers from Darwin. It's right in the edge of our zona economic exclusive zone, our border with Australia. So it's pretty remote. So we need to build logistic supply base within reasonable range from the block. So there are a lot of islands actually near the block. These are the Yamdena Island, and then we have here Arafuru Island, and then we have Tual here, and so many other islands that in the proximity, relatively proximity distance from the block. But we choose the Yamdena Island. We will talk about it later, about the background of choosing Yamdena Island as the project location. But I will show you, this is Yamdena Island, and we will build our location here near the town of Saumlaki. Due to the nature of the project, we have a lot of constraints that we need to consider for the feed or engineering design, and we need to do the site survey and to conduct some data acquisition. The constraints are remote location. As you can see that it's 2,600 kilometers from Jakarta. It's pretty remote. You need to fly for about 4 hours plus 1 hour, 2 hours to the city of town of Saumlaki. So it's pretty remote. Due to the remoteness of the location, we have limited existing infrastructure. There are very limited infrastructure like electricity, clean water, etc. And then very limited local skilled manpower, and also very limited construction equipment. So these are the constraints that we need to consider during the design and the development of the logistics shore base in Yamdena Island. And also these constraints especially the second and the second constraint is the main reason why we need to build the logistic supply base, which is limited existing infrastructure. So we need to build our own independent infrastructure, including clean water, including power generation, including health facilities, etc., and so on. We conducted the site survey, which are general site survey, site boundaries, soil condition and features, existing roads, temporary loading ramp, possibility of a temporary loading ramp, and then cliffs formation, vegetation, seaside observation, existing. Sorry, this one should be existing landfill, and also existing helicopter hangar. And also to do the preliminary basic price, we need to ensure that the logistic shore base could be built using reasonable cost. So we need to conduct a local labor price, local material, and others that we might need during the development of the logistic shore base. And also we need to coordinate with government offices for data finding and permits, like to meteorological and geophysical office in Yamdena Island, also local development planning agency, and then Department of Public Works, Department of Environment, and also National Electric Company for the basis of our development or basis of our design. These are the pictures from the site survey. The site condition, we only have we will build the shore base, as we can tell by the name shore base, should be in the shore or in the beach. So we have to build it somewhere near the beach. These are the condition, and we only have dirt road near the location. These are the conditions. We have cliffs rising from the mean sea level for about 6 meters. But also we have very shallow seawater in the other side, or in the about 1 kilometer from this location. We have this condition on the beach. We also conduct a survey with existing landfill and its facilities. And we also conducted the topography survey using aerial mapping because the size of the proposed logistic base is pretty large, and it's considered impractical to do the topography survey using normal equipments like total station or theodolite. We also conducted the bathymetry survey. Mostly we obtained the data from the Office of Indonesian Navy, but we also conducted a more detailed survey near shore location. And also we conduct some soil investigation. There are 6 boreholes and several that's called penetrometers survey that we conducted to obtain the data of the soil condition. And this one is the pretty interesting, the hazard. We have several hazards in the location of the proposed LSB, which are lightning strike. The lightning strike is considered highly possible because the land feature of the island, there is no pretty large trees over there. So mostly the location is filled with shrubs. So it's not good enough for lightning strike protection. And then also we have earthquake hazard. So we need, which we obtained base rock acceleration is 0.23 Gs. We also have the LS hazardous hazard like a monsoon. Actually, the rain is not that high over there, but we need to consider this as well. And then wild and rabies. There are a lot of I show you here. During the 3-day survey, we already find more than 5 snakes and several other wild animals that could be considered a hazard for our future workers. And also there are malaria endemic in the island that we need to make sure that our worker, our engineer that should come to the location first. We have to be vaccinated before coming to the location. Yeah, the most hazardous ones is the tsunamis. The possibility of the tsunami is pretty high in the location in the Yamdena Island, especially in the southern part of the island. I can show you here in the southern coast of the Yamdena Island is pretty highly hazardous of tsunami, because the fault location is south of the island between Indonesia and Malaysia. So the epicenter of the earthquakes often happen in the area, and then we have to make sure that the proposed location is safe enough for us to build a logistic supply base. And based on analysis, we obtained that the height of the tsunamis, potential height of tsunamis, is about 2.41 in the south part of the Yamdena Island in Tanimbar 2, and about 1.0 meters in the north, in the northern part of the island. And with a return period of 120 to 150 years possibility. And the arrival time is about 52 seconds in the northern part, and then 40 seconds in the southern part from the earthquake time. Yeah, so due to the those reasons, we need to find the safe location and the ideal location for us to build the shore base. We already determined that we will build the shore base in the Yamdena Island, but we need to also ensure that the location that should be appointed is safe from the hazardous from the hazards. Sorry. So we put the location in here. Mostly we base the location determination based on least risk, especially the tsunami, environmental condition, construction strategy, and land availability, and also navigation and permits, because we have existing port here, small port, and there is a navigational route here for the ships to moor in the existing port. So we need to make sure that our facilities is not interfering with existing facilities. And also the tsunami, based on our calculation, we determined that the most highly risk of tsunami is in this part of the island. The height of the tsunami is about 1.0 to 1.2 meters in this area, but in this area we will only have about 0.7 meters, so we will be safe, relatively safe in this location compared to this location. So we determine that this location is the most ideal location for our LSB. After the determination, after the survey, and then hazard identification and also determination of the location, we next proceed to the next step of our front-end engineering design is the engineering design development. First, we need to determine what kind of facilities to be built in the LSB. Based on the BOD, or we call it basis of design, we will need to build 3 major facilities, which are onshore facilities, port facilities, and also hangar facilities with several infrastructures that need to be built in the location. First, we need to, before conducting the detailed engineering design, we need to first conduct the block plan analysis to obtain the most efficient layout of the facilities, because there are so many facilities that will be built, including with 3 categories: the accommodation zones, and then the buffer zones, and also the fire zones. So we conduct this block plan analysis, like by using those 3 zones, we determine that this is the safe zones or the accommodation zone, which the workers and the engineers could do their activities in this location. And this one is the buffer zones, which consists of warehouses and workshops, and also material laydown, with limited number of manpower working here. And then this one is the fire zones, which consist of fuel tanks, powerhouse, and then hazardous storages, infrastructure, other infrastructure like washdown facilities, and also the explosive storage. We need to store explosive and detonators here, because they are needed to conduct the exploration of the gas well in the Abadi block, Marcela block. After the block plan analysis, we conducted the analysis of circulation concept. These are the circulation concept. This one is more detailed analysis than block plan analysis. We already determined the concept of circulation of manpower and also cargos and stuffs. And then we do the development strategy of the LSB facilities. We need to build from center to the outside of the circle here. We need to build, first we need to build the main road, and then we need to build the jetty, the explosive storage, because those facilities needed in the early stages of the project. And then we built fuel tank, powerhouse, and other infrastructure. And then we built warehouses, lay down materials, and workshops. And then in the last stage, we will build office accommodation, CIQP, or bonded storage. And then next we will build the water house facilities. These are the strategy that we need to determine carefully, because we need to consider the constraints that I mentioned earlier, especially the remoteness of the project location. And this is the development concept. Literally, it's the joining of development strategy and also the block plan analysis. So we need to build the facility from this area and then expand it outward. And this is the safety concept. I think we already talked about this in the block plan analysis. This is the image of the built facilities that we need to do. These are the accommodation location with water storage area, offices, clinics, fire departments, telecommunication facilities, and also accommodation facilities. And then these are the workshops and warehouses. This is the material layer down where we can put down our pipes and other large components. This is the explosive and detonator storage. This is the wash down area. This is the hazardous storage. This is the fuel tanks, and this is the retention pond that we need to build to ensure that the water that we already use is not pollutant to the seawater and the environment. And this is the jetty and the causeway and also the trestle here. This is from other angle of the facilities. We need to mention that this is the existing road of this section is only dirt road, so we need to build this road first, and then to also build this our main access road from the public road. And this is the hangar facilities that will be built, including passenger terminal, helicopter hangar, helipads, and etc. And this is the detail of the jetty that we will build. Yeah, the next thing that we need to consider after the design of the facilities, the construction strategy. We need to make sure that the facility is constructible and with a reasonable cost. Yeah, we need to determine a construction strategy for construction pacing. We need to make sure that the pace is in line with other departments that need our shore base, and will be based on the basis of design, site condition, development concept, and strategy. And we need to build first facilities first. The first facilities that needed by the operation should be built first. And then to make sure that due to the remoteness of the location, we need to make sure that the material is timely arrived in the site location, and also the equipment and also the manpower. And then to make sure that the lowest capex or capital expenditure as possible, and then the shortest schedule as possible. We need to build it as soon to finish the project as soon as possible. And then next we need to do the construction stages. The construction stages of the Yamdena Island shore base is first stage is engineering that we already conducted, and then the second stage is the procurement and supply. The third stage is prefabrication and fabrication. The next stage is mobilization, demobilization, and preparation. And then offsite facilities, utilities, building works, pre-commissioning, and safety action implementation during the operation of the logistics support base. We divide the pacing of the development of the LSB into phases. The first phase is meant for that the facilities is ready for drilling operation. So we need port, hangar, and some support buildings like some warehouses. And then in the second phase, we need to make sure that the LSB is ready for operation. So other remaining buildings that hasn't been built in the phase 1 should be built in the phase 2. I highlighted port here because it's a very strategic function in the operation of LSB and other departments that need. This is the chart or the drawing of the facilities that needed to be built during for the drilling operation. This is the most important facilities, which is a jetty and its associated facilities. Lay down area and then warehouses, explosive because we need the explosive for drilling operation, and then wash down facilities, hazardous because the drilling produces hazardous materials, fuel tanks, and CIQP because we will need to import so many equipments straight from their producers abroad outside of Indonesia. And then in the second phase, we will build other facilities that needed for operation. So due to the remoteness of the area, we need to make sure that the construction strategy met with the requirement and is possible to do. So we first determine the temporary stop area, which is chosen due to the shallow water of the beach, and we will be able to show the LCT or barge. So after that, we land the barge on the beach, directly on the beach, and then we will build this facility using earthfill with the area of 82 times 30 square meters. And then all the barge could be beached directly, bringing the materials, equipments, and manpower. And then we will move the construction to this area. This is the location of the permanent jetty will be built. And after we move the equipment and material into this location, we will start build the causeway for the jetty, both using onshore method with the excavator is located onshore, and also this method where the excavator with the material is put on the barge. And after that, after the causeway is built, we will continue with the construction of the jetty. So the jetty is the first facility to be built because we will need the facility to transport the materials, manpowers, and equipment to the location. And after the jetty is built, we will conduct the earthwork. We will conduct the earthwork, the cut and fill work, even if it should be done in stages. We have to start the earthwork in the early phase of the construction. During the earthwork, we will put the early temporary camp here for manpower. So we will put early temporary camp here, and the earthwork start from this location, the access road, and this location for accommodation and offices. After the earthwork is finished, we will move the temporary location from this location to this location. So this would be the main accommodation, and the temporary accommodation will be used as the offices and warehouses. And the earthwork is continued to the beach side, to the seaside. This is the detail of the temporary facilities. I don't think that this is interesting enough for us to talk about, but we will provide, since the location is very remote, we want to build our own facilities like accommodation, offices, and recreation hall, mosques, and other facilities like power generation and water supply. Yeah, after the temporary facilities built, we will build our onshore buildings and facilities. It shall be conducted, well, it's a very conventional method, a bottom-up method. and all equipment, material, and manpower shall be available since our jetty is already finished. So there is no issue for us to transport the equipment, material, and manpower to the site location. Yeah, the problems. Yeah, I would like to talk about the problems here. One of the problem arise due to multidiscipline within our works. Disciplines within LSB department works is civil. We have several civil engineers, structural engineers, architect, mechanical engineers, electrical, HVAC, telecommunication, safety engineers, and quantity surveyor. So there are a lot of people with different disciplines that we need to make them to ensure that they work cohesively. So they will produce a engineering product that meet the requirements and also fulfill the standards of each department, each disciplines. Yeah, the problem is communication, interface between disciplines, boundaries, schedule, requirements, etc. Because there are several requirements that contradicts between one discipline to other discipline. We also have this problem of multi-department because we have several departments within our company like drilling, surf, FLNG, LSB, safety, finance, legal, etc. Also, we have problems about communication, interface, boundaries, schedule, requirements, etc. And also, we will have a multinational problem because the nationalities of the professional within our company comes from diverse countries like Indonesia, Malaysia, Japan, Netherlands, Australia, Singapore, India, and so many other countries. So the main problem is communication. And the second problem is the culture and habit, and then value. Yeah, and also the next problem is the number of documents that should be produced. We will produce, our department, LSB department, shall be produced 260 documents. There is a lot of documents with countless revisions. So we need to make sure that the document used is the latest revision of our document. This is the regulations and standards. This also arise problems during the development. We have Indonesian standards, international standards, company standards, and sometimes the standards regulates similar aspects of engineering works. Like, for example, for designing reinforced concrete, we have our own standard, which is SNE, and then we also have to make sure that it fulfills ACI. And then we also have our own company standard. We call it DEP, or Design and Engineering Practices, and we need to make sure that we use the stringent one. So we have to conduct the analysis at least 3 times with 3 standards, and we will use the stringent ones. So the solutions, first solution is communication. Yeah, this is the highlight of our talk here. We need to make sure that we have the engineers should have a good communication skill. This is the key of finishing the project at hand. We also need to find solutions in method and software, and then superimposing. We need to make sure that the interface between engineers and departments is smooth. And then we also have to do the document controlling, and to do all this, we need to do workshops, meeting, lunch and learn, outbound, etc., to make sure that the project is well conducted. So, yeah, this is the happy side of the engineering work in my department. We need to make sure that the communication between professionals that work in our department is done smoothly. So we occasionally, actually twice a year, we have this get together to make sure that our team is cohesive and able to communicate each other seamlessly. And then we also have so many lunch and learn. We do we need this because we need to understand what other department think about the project. So the structural engineer need to understand the architect's constraint, the mechanical engineer's constraint, etc., and so vice versa. So we need to do the talk a lot, and we did it happily using our method here. We call it lunch and learn. Yeah, this is the other occasion that we did in our department. This is the meeting in the tourist area in West Java. So we need to do the work with intense communication and cohesive team. Yeah, the conclusion. First, I need to emphasize that as an engineer, we have to know to possess engineering skill and know-how, not only in our field, but we need to also understand the engineering aspects of other disciplines. So we will be able to react accordingly, and then we also have to be able to formulate the work staging and schedule of the work. And the third is, I think, is very important, is communication skill, because I don't know in Malaysia, but in Indonesia, one of our engineers, ability is the main ability that we need is communication skill. Most of our engineers could not communicate very well. So I think it is very important for us, especially the students, to develop our communication skill during our study in the university. And then next is management skill. I think this could be learned during our professional works, during OGT or on the job training, etc. And then we also have to understand the regulations and standards. There are so many regulations and standards that we need to fulfill. We need to understand each of them, and then understand of local customs, tradition, and culture. This is the I think very, very interesting for us to understand the customs that different from our own custom and tradition and culture. And the last one, this is the harsh, I think, if I may say so, this is the harsh reality of engineering life. We need to live, well, it's pretty far from the city. We need to travel several hours by sea to reach the closest civilization. So yeah, I think it would be interesting for us. Maybe someday we have the experience of doing such projects. Thank you.
Okay, thank you, Mr. Mukhlis. I think that one is a very good sharing, and I'm very excited to see the. I think the location, the Yamdena Island, is beautiful island. Is it?
Yeah, yeah, it's a little remote.
Wow. Okay, I think I have seen a few questions from the chat box. So maybe I will read one by one. Okay, first question is from Associate Professor Dr. Andre. Okay, hi Mr. Mukhlis. Looking at the risks that you have listed before, was managing the project also means the consideration to pay premium insurance for the worker and the project itself? Okay, is it any possibilities to give the premium insurance to the workers?
Yeah, okay. Yeah, it actually it's different from company to company, but in our company policy, it's the insurance of the workers or engineers or professionals that involved in the project is paramount. So we will have insurance, the insurance that will cover all risk. Since the project is pretty high profile, the company will, I think, will will put a very special attention to the worker welfare, and it is also will ruin the reputation of the company if any of our manpower have such a calamity or accidents. For example, during one of the activity, one of our colleague have a bicycle accident and have to put bed rest for about 3 days in the hospital. Our whole department is we call it stand down and review all the safety and security procedure. So yeah, it's very paramount, and the insurance of the manpower is very well maintained by the company.
Okay, all right, thank you, Mr. Mukhlis. Okay, for the next question is from Nurul Isnani. Okay, salam sir. Did the jetty need the breakwater to protect it from the wave?
Yeah, very good question. We don't need the breakwater here. Maybe I can show you the exact location of the jetty here. In the island. Should be. Yeah. Sorry. Okay, this one. Yeah. Since we will we'll put the jetty here, we don't need the breakwater structure, since the wave is very low. Its average wave height is only 0.4 meters during the monsoon season. Since the location is very well protected, if we can see this, yeah, this is the area. So it's already protected by this island. This island called Adaut village is I forgot about this island. I forgot the name of the island, but it's already the bay of the location is very well protected by the islands. So we don't have very high wave condition in the location. If we put it here, yeah, we will have about 1.2, 1.3 meters of wave. So we would need breakwater. Matter of fact that why we need the location is here is due to the low wave height in the location. So we don't need any breakwater.
Okay, all right. Thank you, Mr. Mukhlis. Okay, so for the next question from the Amalina Hanani. Okay, salam Mr. Mukhlis. When designing the area, did you consider building the shelter when tsunami happened as well?
Yeah, thank you. No, we don't. No, we didn't. I mean, no, we didn't, because based on our worst case scenario calculation, the highest tsunami wave in the area will be about this one, about 0.77 to 1 meters in this area. Unless we build it here in the southern part, it would be 2.41. So, and we have only 1 meter of potential tsunami in the area. And also from the, maybe I can show you this one. Yeah, this is the location of our project. We already have about 6 meters. The elevation of the base will be 6 meters from the average of the mean sea level. So if the tsunami height is only 1 meter, so we are relatively safe in the location. So no, we didn't build tsunami shelter here. Thank you for the good question.
Okay, for the next, statement from Daniel Zita. I love the idea of lunch and learn because I love food. Oh, me too, Daniel Zita.
Yeah, so do I. Yeah, I love to eat very much, especially if it's free.
Okay, right. Okay, the question from Aileen Sophia. Okay, hello sir. May I ask how many times inspection must be done, as the design also considering the tsunami effect?
Yeah, inspection. May I assume that this is the site survey? Because the inspection,
Maybe related to that one.
Yeah, this we conducted so many surveys in the area. First, to gain enough data to determine the location, and also to compare the risks, potential risk in the area that we already chosen. So we conducted several surveys like earthquake survey, peak ground acceleration survey. And then we also conducted the sea bathymetry survey and also the wind and meteorological survey. And to do the calculation of the tsunami is based on those surveys. We also conducted, but I didn't cover here, the UXO or unexplosive ordnance, because the area used to be military base during World War II. So we have to make sure that there is no undetonated bombs in the location, and so many surveys. We also the environment department of the company conducted several surveys for the sea lives, like fish and seaweed and so on. Yes, there are so many surveys that we conducted, but the surveys that related to my department is about 5: tsunami survey, earthquake survey, soil investigation, unexplosive ordnance, and the bathymetry and topography.
All right. Okay. The question from Daniel Zita. Okay. Hello, sir. May I ask, what software did you use when designing a 3D model of your project? Okay, this one is about software.
Yeah. Thank you. Yeah, very good question. We actually use so many softwares, since there are so many disciplines that work for our department. For structural engineers, we mostly used SAP 2000, Structural Analysis Program 2000, and then for the geotechnical engineer, you mostly used Plaxis 3D. For architects, mostly used Revit. I thought Revit and AutoCAD. And then our electrical engineers use their own software. I didn't know the name of the software, but yeah, there are so many softwares that are used during the development of the LSB. That's why I presented the communication is very important, because since there are so many survey softwares, there are so many analysis results. We need to make sure that the interface between these disciplines is smooth. Yeah, there should not be any conflict between one discipline and other discipline. So yeah, there's a lot of softwares, and we need to make sure that they connected each other, interface each other smoothly.
Okay. Mr. Mukhlis, the question is from Tracy Nelson, I believe. Okay. Good evening, Sir Mukhlis. Are the company regulations and standard similar for each of the country that involved in this project?
Yeah, there are the company policy. Our company policy is to use the stringent one regulation. We have our own standards, our own national standards. We have to obey the regulation and standards, and then we also have other international standards, and also we have our own company standards. So we need to consider those three standards. So is it the same regulation and standard? Well, it's mostly not, but we have to use the stringent one. Yeah, that's the hard thing that we have to do, because we need to carefully ensure that the standards, all of the standards, national, international, and company standards is fulfilled.
Okay, all right. For the next question is from Susan Sugianti. Okay, hello, Mr. Mukhlis. I'm civil engineer student. May I ask, you mentioned communication skills quite several times. And based on your experience, what are the crucial things that might have a big impact to the projects that caused by bad communication skills in engineering?
Yeah, well, the impact of bad communication skill is a lot. Yeah, it might be not that catastrophic, but sometimes it makes very the consequences is very high due to the bad communication. For example, when the location of the piping was planned to be laid is crossing the retention pond of the civil engineer, and the location is already excavated for the pond, and due to the regulation of the high pressure pipe, they can't just bend the pipe to avoid the pond. So we need to, after the excavation of the pond, we need to fill it again with the soil and put the pipe there and move the pond somewhere else, only due to a bad communication. And we need to, we waste so many man hours for the work, and it's for us it's pretty catastrophic. So yeah, we need to make sure that our communication, interpersonal, interdepartment, interdisciplinary communication is smoothly conducted. And one of the manager tasks is to make sure that the communication and the interface between engineers is smoothly conducted and without conflict.
Okay, I think this one is the last question from the chat box from Darshini Sivasamugam. Okay, hello sir. From your opinion, do you think that offshore construction is the most challenging one compared to the others? Okay, what is your opinion, Mr.
Yeah. Very interesting question. Actually, both onshore and offshore construction have their own challenges. But for us, structural engineer, the offshore construction is pretty challenging due to the harsh environment, the different consideration, like loading consideration is very different. Yeah, we do not have earthquake on offshore, but the wave loads, the wind loads is pretty significant, and we need to make sure that our structure is very well built, and the safety is, the safety requirement is met. And also we don't build infrastructure or structure offshore without any good reason, right? So the reason that we built offshore construction is to support the industrial activities or exploration activities offshore. And the requirement of the activities is very different with other structure or infrastructure onshore. So the consideration is much more, much more wide, much more variable than the onshore construction. So yeah, I think the compares to onshore construction, offshore construction is more challenging than the onshore construction. But that doesn't mean that onshore construction is easy. Actually, we have our own challenges also in onshore construction. Yeah, at least that's my opinion.
Okay, thank you, Mr. Mukhlis. Okay, and then I think this one is the last question for me. Okay, actually, I'm quite attracted to your analysis that you mentioned quite a lot about the communication skill is very important when we are dealing with the different parties to the project. So maybe can you give some motivation or some suggestion to our students on how to develop a good communication skill from now, before they come up and work to the private sectors or government or any other project to handle any projects. Okay.
Yeah, thank you, Dr. Saraya. Yeah, I don't know about the curriculum in Malaysia, but in Indonesia, most of the engineering school in our universities doesn't include the communication skill in the curriculum. Mostly we concentrate on the engineering aspects to study. So for my students, I encourage them to be involved in so many extracurriculum activities like student body or other activities that involve teamwork and intense communication between personals. That way we will we will develop our own communication skills, and to make sure that we will be able to convey the message correctly, timely, and mannerly to other personnel or other departments that we need to work with as a teamwork. So yeah, I think we need to beside our main activities to do to study in the university, we also have to develop our soft skill somewhere else, extracurriculum. Like student body in Indonesia we have student body. I believe that in Malaysia also have student body, and with so many organization activities, I think that would be a very good facility for the students to develop their communication and teamwork capability. And also in Indonesia, we have we call it tugas besar here, or tugas besar in bahasa Indonesia, to do the several design works like bridge design, building structure design, and they did it in groups. So during the assignment, they have to communicate between their team member to finish the project that assigned their professors or lecturers. So those two facilities or activities should be able to develop the communication skill of the students. So don't only focus on the study in the university, but we need to develop our soft skills somewhere else. It would be much better if we did it inter-university with other students, but yeah, we can obtain the soft skills somewhere from so many activities and facilities that are available for us.
Okay, thank you, Mr. Mukhlis. So we can conclude that the soft skill is very important and not only focusing on the academic part, is it? Okay,
Yeah.
okay, so thank you,
Thank
Mr.
you.
Mukhlis, again for your good sharing session and for the lot of tips from you. So it is hope that all of us will benefit from this good sharing session. And I think maybe this is the last for this evening, the last slot for this part. Okay, and then I think that's all. Thank you, and I will pass back to our Miss Chairperson. Okay, for this platform. Okay, thank you from me.
Okay, thank you to our speakers and Associate Professor Technologist Dr. Suraihani binti Abdenan for conducting slot 10 just now. We hope this sharing session can provide beneficial knowledge to all participants.